Okay, so here I'll show how you can convert your pressure export data from AeroSim solver into pressure coefficient data. First of all, you will have to export your pressure reference probe and also the body export, usually where you export the pressures around your body of interest here. So as for the pressure reference and the pressure probes, it's important that the same exported period, initial time and end time, is used so that you can do the post-processing correctly. After you finish your simulation, you have two options of download here available. So you just have to download both the H5 and the XDMF file so that you can open the historic series with Paraview. And here I have already opened both XDMF files. Here I have the pressure reference and the pressure probes here at Paraview. Here is the pressure reference XDMF. So the first thing you have to do is to convert the pressure reference data to point data. So you just have to click with the filter point data to CellData. If you want to have a quick access to the filters, you can just press Ctrl space here at your keyboard for a hotkey, and you can just type the filter point data to CellData. Here it's only pressure, so you just have to convert this to CellData. After that, you have to group both data sets here. So you just have to select this data set and this data set here. So, and use the filter group data sets. This might take a little long to process, but it's important here that the reference pressure here be the first block and the second block being the pressure probes to match the filter I'm actually providing for this. So done. Now you just have to apply the programmable filter I'm providing, in which you just use a Python code to do this subtraction here. And this filter will be, the result of this filter will be the pressure difference for each point of the pressure probes and the pressure reference here. So after applying this programmable filter, you will have another variable, which is the difference between the pressure on the surface and the pressure on the pressure probe. So this variable here, pressure difference. From this variable, you just have to apply the calculator filter. And here, with the calculator filter, I will just compute the pressure coefficient, the CP, and just let me pick the pressure difference, and divide the pressure difference by the dynamic pressure here. I will assume here a 30 meters per second velocity with 1.24 for the air density and 0.5 here, which is from the formula. So here just apply the filter. Here you will have now the time series for the pressure coefficient. You can select it for an instantaneous pressure coefficient here, and if you want to visualize the values, you can just open here the spreadsheet view for this filter. If you also want to do the statistical processing with Paraview, you can just use the temporal statistics field here, this one. This filter takes a while to process, but in the end here you can compute average values, the standard deviation values, and also the standard deviation values, and also the absolute peaks, minimum and maximum values here. And after that you can check the values you computed. I'm not gonna process this filter because it takes too long. You can just check the values with the spreadsheet view. Here you have the option to export this in a CSV file as well.